When it comes to symmetric algorithms, we have this technology called Rivas cipher. It was created by Ronald Rifus, aka Ron's Code, on RSA Laboratories in 1987. It has its current levels are 4, 5, and 6. It is a stream cipher, which means it will encrypt every byte of data. Okay, so stream cipher, I'm going to encrypt every byte of data that comes through. It's used in SSL, TLS, WEP, WPA encryption, and simple Windows VPNs over point-to-point tunneling protocol. RC4 is used to obfuscate the header and stream when downloading BitTorrents when it makes it hard for ISPs to notice. Not considered strong enough for today's use, so we shouldn't be using it. Key sizes vary from 40 to 2048. Now we have this thing called DES, or Data Encryption Standards, created by IBM in the early 1970s and adopted by NIST in 1977 and later adopted by the U.S. government. It uses a random key designated for a large number of shared keys. It is based off of IBM's Lucifer cipher, and this is a block cipher where it not only encrypts the data, but it'll encrypt it in blocks of data rather than a single byte. So this block cipher in DES, it uses a 64-bit block and a 56-bit key within 8 bits of parity. Limited in its uses and no longer considered secure due to its short key length, and it is easily broken. When computational power made brute force attacks more feasible, DES was no longer a viable encryption option. So you should not be using DES in today's standard. However, DES is a symmetric algorithm. Now we have triple DES, or 3DES, was developed as a countermeasure to address the shortfalls of DES itself. It is more secure than DES by implementing a threefold compound operation for encryption and decryption. It still uses the same 64 block size, and common keys sizes are 168, 112, and 56 bits. It works by encrypting 3 times with a new key each time and using the output for each rotation as the input for the next. It is used by the U.S. government and the civilian sector for applications like tunneling virtual private networks, or VPN. Triple DES is still significantly hard to break, but you should still use AES since it is more preferred. So what we have here in this picture is we have our plain text and we have our first key. We use that symmetric algorithm, turn it into ciphertext, and we take that ciphertext and we generate another DES key, ciphertext that, encrypt that, and then take that ciphertext, encrypt it one more time, and that's how triple DES works. The next algorithm is Advanced Encryption System, or AES. It is a replacement for the unsecured DES. NIST held an extensive multi-year research period in a competition between U.S. government, academia, and private industries to develop a stronger block encryption technique. And the winner is Rindahl. It is pronounced Rindahl algorithm, and it became the new advanced encryption standard. It was designed by 2 Belgian cryptographers, and Rindahl was chosen as the new AES, or advanced encryption standard, because it displayed consistently good performance, efficiency, and ease of implementation when utilized with both hardware and software. Its low memory requirements make it well suited across a wide range of computing environments. In addition, its operations were among the easiest to defend against power and timing attacks. AES is the current standard and is used with smart cards, mobile phones, and WPA2. It uses a 128-bit block cipher with encryption keys of 128 bits, 192, or 256 in length. And actually, to this recording, they have higher bit lengths right now. AES is an open standard and is patent-free, and it does not have any known practical attacks. The last two are Blowfish and Twofish. Blowfish was published in 1993, and the block cipher that that an encrypt using an any size chunk of data and operates using 64-bit blocks with key lengths from 32 to 448 bits. Very fast speeds, except when changing keys. Two Fish, published in 1998 by the same person, Bruce Shiner, and his team to compete in the AES competition, but lost to Rindahl algorithm. Similar to Blowfish, but uses larger block size and more complex key schedule. Block cipher operating on 128 bits with key lengths from 8 to 256 bits. The most common key lengths are 128, 92, and 256. This was one of the competing algorithms for AES.